Hi guys, so today we are going to be going through a statics problem. This is from chapter 6 of the book, so it's going to have to do with moments about axes. Hopefully that's going to help you with some of your homeworks, and if you have any questions, definitely email me and we can go over it in person. But yeah, let's get started. So this problem is asking about three forces that are acting on a rectangular box. I drew the picture from the problem, and basically the book is just giving us three different forces that are acting on the boxes and their distances from each of the axes. And then from there, we're going to be able to determine the moments. Okay, so the first thing that we're going to do is look at the 50-pound force that we were given in this scenario. So let's start with the x-axis. Basically, all that moments are is looking at how far the moment is from the axis that we're talking about. So if we're starting with the x-axis, that means that we're looking at the 50 pounds, and then we're multiplying it by that 4 inches that it is from the x-axis. And then we just multiply, and obviously it's counterclockwise because it's positive. So now we can move on to the y-axis. It's pretty simple here because there actually isn't a distance between the y-axis and the x-axis. The y-axis and the force. So again, you're just going to do that 50 times the distance, which is 0 in this case. So we have 0. And then lastly, the z-axis is the same thing. We're going to do that 50 times that distance of 0, and we're going to get 0 again. Okay, so now we're going to move on to the 80-pound force. So in this case, if we're trying to figure out the force about the x-axis, the 80-pound force actually has a force of 0 about the x-axis, because when you look at the way that that force is moving, it has no impact on the x-axis at all because it's going in the same direction. So we would do that force of 0, and then with the distance 4, but 0 times 4 is 0. So like I said, that force is going to be 0. Now we can look at the 80-pound force about the y-axis. In this case, we can multiply that 80 by the distance between the force and the y-axis, which is 6. From there, we're going to get 480 pounds per inches. Again, since that's positive, we'll say it's counterclockwise. And then finally, we can look at that 80-pound force about the z-axis. So what we're actually going to do is make that a negative because of the way that the force is interacting with the z-axis. That would make that force negative. So we'll do that negative 80 times the distance, which is 4. And so then we will get that negative 320 pounds per inches, which means since it's negative, it would be clockwise direction. Okay, so finally, we're going to look at that last 60-pound force that we have acting on the box. So it's the same thing here. We're going to do that 60-pound force and then times the distance from the x-axis. So that is 6 inches. So 60 times 6, 360 pounds per inch. Again, these are positive values, so we're going to go with counterclockwise. And then we're going to do that 60-pound force about the y-axis. So same thing here is that the force is acting in the same direction as the y-axis. So that means that there would be a force of 0. We can multiply it by the distance from the y-axis, but we'll still get 0. And then lastly, we'll do that 60-pound force about the z. So like I said, the way that it's acting means that we would make that a negative force and then times the distance. So we will get that negative 60 times 10, which means it'll be a negative 600 pound times inch force. And then since it's a negative value, that means it's acting in the clockwise direction. But yeah, that's about it for that problem. Like I said, if you have any more questions, please let me know. I'd be happy to explain. But this is just your standard moment about an axis problem. So good luck with your homework. And like I said, let me know if you have any more questions about this problem or anything similar to it.